So in this video we're going to go through the differences between AC and DC power sources. So I've put together a visual demonstration using every circuit, so I'm not going to go into any particularly advanced details, but I'll make sure that you can understand the fundamental differences between AC and DC power supplies. First of all, let's focus on DC. It's the easiest concept to get your head around. If you've seen my previous video regarding electron flow, then we actually talked quite a lot about how electrons flow through a DC circuit from a battery. If you want to learn more about how batteries actually work, then my previous video will definitely fill you in on that, and you should see an annotation above. You can go ahead and click that and watch that video. AC and DC circuits, the differences between those two are basically the differences between how the electrons actually flow through a circuit or from the power source. In a DC power source, such as a battery, the electrons flow in one direction and one direction only. The electrons come from the negative side of the battery and flow towards the positive side. The positive and negative side are both constant, they do not change. So that means that the electrons flow from the negative side through whatever is in the circuit, such as an LED, and then towards the positive side. And that's why DC is known as direct current. It flows one way in one direction. Now, AC circuits are completely different. AC stands for alternating current. Now this could be the AC circuit which exists in our homes. Our homes are all usually powered from the grid, and the grid supply is actually an AC power source. The reason why the current is alternating back and forth like this is because if we go back to the DC circuit, where the positive and negative always stay constant, in an AC circuit, the positive and negative poles are changing for every cycle. So very quickly what happens is the positive and negative poles swap at a certain speed, and we'll get to that in a moment. But as those poles swap around, if you remember the previous video, electrons always flow towards the positive side. So if we actually swap positive and negative, then the electrons that were previously flowing in the circuit will then suddenly want to flow backwards, because the electrons will then want to flow towards the positive. And that's what's happening very quickly in AC circuits. In the case of the UK, this happens 50 times a second, and in the case of the United States and most other places, it happens 60 times a second. So positive and negative poles swap at about 50 or 60 times a second, pulling back and forth the flow of electrons. Now, why does that happen? What's the reason behind that? Why do our homes not get supplied with direct current? It's actually all to do with the way that the power is generated at power stations. At power stations, heat and steam are generally used to power turbines, and those turbines actually generate AC current. They do that by passing magnets through coils. The turbine actually pushes and pulls magnets through a coil. And because the turbine pushes and pulls a magnet through the coil, that is in turn generating an AC current. And that AC current is what's distributed throughout the national grid. So look for the next video on Simply Electronics, where we go into how alternating current is then turned into direct current to power the devices that mainly rely on direct current in our homes.